Hello. In previous lectures, you have learnt about properties of laser, different types of interactions between radiation and matter, including stimulated emission, which is the basis of laser. Other essential phenomena other than stimulated emission of photon like population inversion, pumping, and the requirement of metastable state were also being discussed. In this lecture, we shall discuss two examples of laser, namely ruby laser and helium neon laser. These are the examples of the solid state laser and the gas laser respectively. So let us start. The first example is the ruby laser. A ruby laser is the first ever produced doped insulator laser and is an example of solid state laser. The base material in it is Al2O3, commonly known as sapphire, doped lightly with chromium ions. By doping, aluminum in Al2O3 is replaced by chromium ions. For a good lasing action, the doping is approximately of the order of 0.05 weight%. By this, the crystal of Al2O3 appears pink and as a whole is known as ruby crystal, which acts as active material for the ruby laser. In this laser, the stimulated emission of photons were provided by chromium ions. Ruby laser works on three-level pumping scheme, where the pumping energy was initially provided optically by xenon flash tube. This is the picture of real ruby laser, where this is the ruby crystal and xenon flash tube is warped around it. In this picture, ruby rod is placed here and this rod is polished at both flat parallel ends. The reflection is 100% for incident photons at one end and 95% at another end. These reflecting surfaces make the laser cavity for the stimulated emission to happen. The laser emerges from the side with 95% reflecting end. The energy levels of system are shown in this figure. Here, these two levels are broad ones and have lifetime of about 10 nanoseconds, whereas the narrow level is a metastable state and it has the lifetime of 3 milliseconds. As the xenon flash tube is fired by discharging a capacitor through the tube, the chromium ion in its ground state can absorb green photons with wavelength of 660 nanometer and make a transition to one of the states in this band. It could also absorb blue photons of wavelength 400 nanometer and can make a transition to one of the state in this band. In either case, it immediately makes a non-radiative transition to metastable state. The excess energy is absorbed by the lattice and does not appear in form of electromagnetic radiation. Also, since metastable state has a very long lifetime, the number of atoms in the state keeps increasing and may achieve population inversion between metastable state and ground state. Once population inversion is achieved, light amplification can take place through stimulated emission. Thus, ruby laser is an example of three-level laser. One important issue or the characteristic of ruby laser is that the flash operation of the lamp leads to a pulsed output of the laser in the short period of a few tens of nanoseconds. This phenomena is known as spiking and can be understood as follows. When by discharging a capacitor, the pump is suddenly switched on to an intensity much above the threshold, the state of population inversion builds up. And when the population inversion state crosses the threshold, the photon emitted rapidly up to a number very much higher than the steady state value. Since the photon number or the number of stimulated transitions is higher than the steady state value, the rate at which the upper level depletes is much higher than the pump rate. It is because the number of stimulated emissions is directly proportional to the incident photon flux. Consequently, the inversion becomes below threshold and the laser action ceases. At this case, the emission stops for a little time. Within this time, the flash lamp pumps the ground state atoms again to the upper level and the laser oscillations begin again. And this is the cause of pulses in ruby laser. After ruby laser, let us discuss an example of a gas laser, the helium neon laser. In helium neon laser, the active medium is the mixture of helium and neon gases in the ratio of 10:1, and this is filled in a quartz tube put between two parallel mirrors, out of which one is fully reflecting and another is partially reflecting. The required energy for pumping is provided by an electrical discharge. This is the schematic of the system. Here, this is the quartz tube filled with helium and neon gases. This is the power supply for the electrical discharge in the tube, and these two mirrors are providing the laser cavity, and the laser emerges out from the side of 95% reflecting mirror. Let us discuss the mechanism of helium neon laser. The lighter helium atoms are more easily excited than the neon atoms. There are two metastable states in helium, and these are represented by F2 and F3 in this figure. Helium atoms may return to their ground state by transferring the energy to neon atoms through collision, and by doing so, they bring neon atoms to one of two metastable states of neon, E4 and E6. Now, when the neon atoms jump from one metastable state from these two to another metastable state, E5 or E3, they emit the stimulated emission of 3.391 micrometer, 1.15 micrometer and 632.8 nanometer, among which radiation of 632.8 nanometer lies in red visible range, and this is the laser output. After this, the neon atoms finally return to ground state by collision with walls of the tube. After discussing the mechanisms of ruby laser and helium neon laser, we can compare these two lasers. The gas lasers are more directional and monochromatic, because in gases there is no possibility of crystalline imperfections, thermal distortions and scattering, which is the problem in solid state lasers. Secondly, gas lasers are capable of operating continuously without need of cooling, because cooling a solid body is difficult. Next, the ruby laser is a pulse laser, while gas laser like helium neon laser is a continuous laser. In ruby laser, the pumping is usually done using a flash lamp. Such a technique is efficient if the laser system has broad absorption bands, like in ruby crystal. But in helium neon laser, since the atoms are characterized by sharp energy levels as compared to those in ruby crystal, electrical discharge is used to pump the atoms. Finally, it can also be said that gas lasers are easier to make than solid state lasers. And it is because the process of 4-level laser is easier than that of 3-level laser. So, in this topic of lasers, you have learned about the properties, procedure, types and examples of lasers, in which two examples of solid state laser and gas lasers were discussed.